Thank you, Woody, for creating such a wonderful program that we've all been able to enjoy here on this first, second day. I also would like to thank Robin Gentry-McGee, CEO of Nutritional Medicinals, the manufacturer of the only organic whole food meal replacement that's used in hospitals by the critically ill all around the world. It's one of a kind. Thanks for this opportunity to be here with you. And I also want to thank Brian McGee for his help with the slides that I'm going to share with you tonight. I really only have a limited amount of time with you, so I really need to dive in. And I hope that from what I've heard, I can build somewhat on Dr. Perlmutter's talk that he gave this morning on the microbiome. It's for many people, it's an area of incredible interest. Will you be able to see okay from over here? Yeah, okay, great. So, I think some of the things that I'm going to share with you, this evening are going to be a little surprising. I think that by now most of us have heard that there are certain things that are very detrimental to the diversity of our microbiome and to particular species or families of bacteria. But I'm going to add a little bit to that layer, and I want to spend a considerable amount of time this evening on the tight junctions. Those are, in essence, the doorways that allow things into our circulation, for better or worse, and they have an enormous influence on our health, especially inflammation. So, and I have to say one thing as a disclaimer. I'm not responsible for the casein content of the cheese or the gluten content of the crackers. So, if you're not familiar with those two areas, you'll certainly learn more in a moment. The wine is fermented. That's a good point. So if we take a look at, what it is we really know about the microbiome and about the importance of diversity and those things that influence it, we know that, things like fermentable fiber are important. We'll get to that in a little while. And we know that our exposure to a wide variety of antibiotics, whether that's food residues or those which are prescribed, are also major influences. So these, there's some of these things which have, over the last decade or so, really been brought to the forefront in terms of what we actually know. We also know that the microbiome plays a huge role in not only metabolism, but in immunity and in the overall innate inflammatory response. And whether you're talking about diabetes, which is very well established, or you're talking about a variety of lung disorders, from asthma, of course, which also has an enormous inflammatory component, to chronic obstructive pulmonary disorders, there's really strong connections now between the inflammatory response, which is the result of either dysbiosis within that microbiome or high levels of intestinal permeability, which, of course, go back and forth. I mean, there's a strong level of interplay between the populations of bacteria, the microbes, which colonize various areas of the intestinal tract, and the level of permeability that you will find within those regions. So this is really the duo that we're speaking to tonight. Now, within the particular families of bacteria that show up, for instance, in a case of metabolic syndrome or obesity, it's really clear that you have certain families such as, Fecalibacter prosnitzi, which is very important. We'll get to that in a moment in terms of generating butyric acid. And we know that Bifidobacter is certainly diminished in the obese and in those with metabolic syndrome. And it's very hard to recolonize once they're lost with some of these species because they, again, it takes a certain environment for them to gain a strong foothold and to be well represented within this. But overall, when we start to take a look at these families, it's not always whether they're present or not. It's also the levels with which they're present in terms of ratios to those microbes and to other forms of life, fungi and yeast. And it's the interplay between them and the ratios of their populations that often speaks more as to the absolute value of them. When you take a look at some of Martin Lawson's papers, and this is his most recent from just last month, on what it is we actually know about this role of environmental dietary factors in diversity, a very small percentage overall, 10 to 11% of that variability can be explained by some of the things that we typically turn to first when we look at that relationship. The strongest correlation or association, if you look at Pearson's correlation coefficient, and I know that for some of you at the back of the room this may be difficult to see, but the strongest correlation coefficient is a 0.31, which is not a very strong overall relationship between protein and microbial diversity. And as this previous slide showed, we can't actually predict as many of us have been told over the last 10 years, you can't actually predict that because the mother maybe had metabolic syndrome or obesity, you can't always predict that the child or the children within that household will have the same populations. It tends to shift that way over time, but there are numerous factors that I feel are taken for granted. Fiber is one of the big ones because we often hear more fiber, and that's going to support higher levels of diversity. But when you take a look at that correlation coefficient, it's only 0.2. So it's not a very strong overall association between absolute fiber intake and diversity. However, as we get into this talk in a little while, we'll take a look at different types of fiber, and you'll maybe understand why the absolute fiber doesn't show what we'd expect it to. And with carbohydrate intake, which we'll spend a considerable amount of time on, you can see that there's a very poor, less than 0.1 Pearson's correlation coefficient between carbohydrate intake and diversity. And this is also really important because I think many of us have read in various journals over the last 3 or 4 years that having microbially accessible carbohydrates is one of the most important building blocks for intestinal diversity. And I think, again, a further explanation of what microbially accessible carbohydrates are is really a worthwhile discussion. So this is a molecule that we do know an incredible amount about, and this is butyric acid, or N-butyrate, and this is what is one of the preferred fuel sources by the cells that line our digestive tract. Without an adequate supply of butyric acid, the gap junctions, which ultimately, again, serve as that primary barrier between our circulatory system and all the organs that it's in contact with, and the outside world, in this case the microbiome, it really starts to break down. And what are the bacteria or the families that produce the most butyric acid? Well, certainly, I mentioned Bifidobacter a moment ago, and that would be at the top of the list of one of those families that is really important. It's pivotal with respect to butyrate generation, as well as Faecalibacter prausnitzii, which we know once that disappears, people become much more inflamed overall, everything held constant between a control and an intervention population. And again, once N-butyrate starts to disappear from that currency of energy source within that GI, that's when we start to develop this high level of intestinal permeability or leaky gut syndrome at an extreme level. So let's just talk for a moment about intestinal permeability. And again, this talk is on inflammation, how it is you curb inflammation from within the GI. This is one of the most important concepts within that discussion, because once you have a high level of intestinal permeability, which was given to us over the course of evolution to allow our bodies to have just enough exposure to particular antigens that would allow our immune systems to recognize them with subsequent exposure. So this is a really important mechanism. Whether you're talking about the role of zonulin or you're talking about some of the effects that particular microbes have on the gap junctions, that has served us really well over the course of human history. Without that mechanism, we would never have had the immune system adaptation that would allow us to successfully overcome chronic exposure to pathogens, either in drinking water or within our environment. But this is a list. This is a wonderful paper, if you're not familiar with this, by Stephanie DeSantis, on the different nutritional factors that have been shown to have significant impact on the gut barrier and on those tight junctions. And you can see that there's a long list of things that have been fairly well established over the course of the last 25 years or so. Things like zinc depletion. Most people are not familiar with the role that zinc plays in maintaining tight junctions and generating occludin and claudins, things that really serve as the cement between those cells. But there's a long list that, have clearly demonstrated the ability to either strengthen this rebar material, in essence, these tiny protein filaments that we know as claudins and occludins. These are really what hold everything together. And once they start to be digested or broken down by whether it's gluten in predominantly gliadin, particular types of fats, which we'll take a look at in a moment, or alcohol, especially if alcohol is combined with the wrong types of fats, or if alcohol is combined with fructose, then you really have 1 + 1 = 5, because the two really play off of each other. But this, in essence, is what we're trying to do. We're trying to, for lowest level of inflammation and for optimal health, we're trying to maintain a very high level of intestinal wall integrity while still allowing for the acute exposure to particular microbes from time to time that will allow the immune system to rally, recognize, and be there in the times that we need that. So I'll start with one that you're probably familiar with, and this is A1 beta-casein. A1 beta-casein is the predominant source of casein now in the Western diet. And this is very simple as to why. The Holstein cow represents about 94% of the Western diet's dairy supply. Very different A1 casein than A2 casein, which comes from older breeds of cows which have largely been displaced because they don't generate as much milk in a typical year or 300-day milking cycle. I think this is one of the real important topics under the umbrella of dairy and inflammation. So many of us have heard how dairy is damaging at one level or another, and it's really important to understand the details and the differences within that dairy world. There are populations around the world that have very, very high levels of dairy consumption. Whether you're looking in pockets of Africa where people do not have lactose intolerance, whether you're looking in areas of India where people rely very heavily on milk for a major percentage of their protein or calories, when you look in these areas, you find that you have very robust levels of health, but the common denominator is that the milk is not sourced from a Holstein cow. In India, it may be from a Brahma cow. In Africa, it may be from a red pole. It may be from a different variety of cow that does not produce A1 casein. By the way, goats and sheep also produce only A2 casein, so they're also should not be lumped in with that inflammatory casein family. But they really only differ in one amino acid, which is fascinating, and that's the proline and histidine difference. When A1 casein is partially digested by the digestive enzyme secreted by our pancreas, you end up with a small fragment known as BCM7. And this has been implicated in a large number of autoimmune type reactions that people have, autism, a variety of health conditions. And the governments of New Zealand and Australia have really done a remarkable job of separating this. And it's led to the development of A2 milk. Maybe some of you have seen that in the last couple of years. It's now for sale in California and Colorado. Because the research is very clear. A1 casein is the risk factor with dairy, not A2 casein. I'll try to leave time for questions at the end of this. If we take a look at the research by Mohammed Reis, it's really fascinating. When you take a look at two particular markers of intestinal inflammation, what you see is that with A2 milk, there is no spike in myeloperoxidase. There is no spike in interleukin-4. But by the time you get to something that's half A1 and half A2, you've got a significant increase. And once it's all A1, which is, again, a typical Holstein milk product, you have inflammation levels that are 2 and sometimes almost 3 times higher than what you get with the control group or the A2 milk. So very significant differences based on that tiny amino acid difference between A1 and A2 casein. Another protein that I think most of us by now understand at one level or another, and that is the role of gliadin, again, which is the predominant type of gluten. It's found in members of the wheat family. Gluten and gliadin both result in exposure to them, result in the generation of zonulin, an enzyme first discovered by Alessio Fasano, now at Mass General, which basically digests those tiny filaments I spoke of earlier, the claudins and the occludins. This allows those cells to move apart and to migrate very quickly. And even in people who don't have celiac disease, the zonulin response is across the board in every single human being. In fact, it's in most mammals. So this is not something that is only a problem for those with celiac disease. This is a response that every single human being has. Now, for those who have that particular HLA-DQ2 or HLA-DQ8 gene, for those who have that expression, then this zonulin response causes much longer-term damage and gap junction compromisation. But for those of us who do not have celiac disease, you're still looking at a 4 to 8 hour window of time with chronic exposure to gluten with which the tight junctions are compromised. So those are two of the dietary factors that most of us have some level of exposure to with respect to increasing intestinal permeability. So we have gliadin and we have A1 beta-casein, both causing a breakdown of those gap junctions. Now, what about some nutrients that are much more widespread, that are found in a lot of different foods, even if gluten and casein have maybe been on our radar, been on the radar for our patients? One of the biggest ones is fructose. And when I'm talking about fructose, I think that most of us understand that high fructose corn syrup has its own set of perils. If we've looked at the work by people like Robert Lustig at Stanford or Paul Stanhope, and you've looked at the radical difference in the metabolic response to fructose over glucose, it's really clear that it has a very high inflammatory component, that it generates massive amounts of triglycerides in comparison to glucose. Well, the microbes within our GI play a pivotal role in that inflammatory response and how much this puts us into the anabolic or storage direction. If you take a look at the fructose, the response to fructose, you have twice what you get in the controls. And if you administer antibiotics at the same time that you do the fructose, you do not get the same level of inflammation. And in fact, if you give the laboratory animals a fecal transplant, very soon after the fructose is administered, again, you have a marked reduction in that inflammatory response generated by the way microbes within the GI respond to that fructose. And this fructose doesn't have to come at the pharmacological dose that it is represented in corn syrup and soft drinks. It's been shown that even having a big handful of dried fruit, again, a disclaimer, I think there's dried fruit on that plate, just having a big handful of dried raisins, which of course is much better than having corn syrup or having the concentrated sweeteners, there's enough fructose in a high volume of dried fruit to cause a very, very similar reaction within the GI. So I think a lot of the foods that we look at as being all natural, being much better choices than the concentrated sweeteners that are in so many foods, they also fall under this umbrella of being a high fructose source. And the research shows that when you consume anything more than 10 grams of fructose at a given meal, this starts to happen. And in some individuals who maybe already have a certain level of dysbiosis, it's much worse than in others. But I think the ceiling has been set, again, by Dr. Lustig and Stanhope, that 25 grams of fructose per day is really the ceiling we should look at in keeping populations under that. And it can be done by just eating whole, fresh fruit and staying away from most of the concentrated sweeteners and other sources. Another, and this is a really interesting area right now within the field of nutrition, is the role of polyunsaturated fats on this intestinal permeability. I think most of us, and I'd certainly put myself in this category, were at one time or another taught that polyunsaturated fats were the heart healthy fats. Like those were the fats that you really wanted to use to lower your cholesterol levels, to produce less inflammation. And what the research has shown in the last several years is that in fact polyunsaturated fats, both omega-6s as well as EPA, eicosapentazoic acid, which is found in your marine oils, both of those cause a breakdown of the claudin and the occludin, again, the tiny proteins that hold together the intestinal wall and keep the permeability at a healthy level. Both your omega-6s, which again do have the ability to generate inflammation if they're out of balance, as well as EPA found in marine oil, both of those cause a marked drop-off in claudin and occludin production, and this allows that high level of intestinal permeability, which people who have done clinical work with alcoholics have known for years, because it's been shown that if you have a recovering alcoholic and you give them a diet higher in saturated fat with a very low level of polyunsaturated fat, that their livers do much, much better. You have markedly lower levels of liver enzymes and other indicators of an inflammation, and in terms of what's going on with respect to lipid metabolism. So really the summary of this paper by Kirpich, which I think is a great one, is that polyunsaturated fats, when they become more than 3% of an animal, and this has certainly been shown with humans as well, more than 3% of the diet, you're going to have a certain level of intestinal wall breakdown, a higher level of intestinal permeability, and it's important to make saturated fats really the foundation for the fats in the diet. So what about, again, I mentioned the EPA, eicosapentazoic acid, which is found in your fish oils, your cod liver oil, and things like that, which at one time in my career I was a much bigger fan of than I am now. If you take a look at the work, and Sanjay Ghosh, I'm not sure how many of you are familiar with the work of Sanjay Ghosh, but he's in British Columbia, and his research now for over 5 years has shown that adding fish oil to the GI, to the microbiome, is very disadvantageous for most people, that it causes a higher level of inflammation than most of us have been led to believe. It causes aberrations within the innate immune response in that environment. So this is not necessarily the newest research, but it's one that I think most of us should appreciate when we start talking about the microbiome and intestinal permeability. Because I think, a lot of us hear good things about fish oil. And what I'm sharing with you tonight has not been shown with eating oily fish or eating the actual source. This has only been shown with adding the oil to the microbiome. But what you get is you have high levels of prostaglandins of both the series 2 and the series 3 variety. And again, the prostaglandins, which are a type of eicosanoids, those of the series 2 and 4 variety are typically associated with inflammation. And those are generated when we have higher levels of omega-6s in our diet. But what Sanjay Ghosh and others have shown is that the EPA for marine oil, that causes also very significant aberrations within our prostaglandins of the series 3 variety. And this causes higher levels of tight junction permeability, and it causes a breakdown of the occlusion. So what about other types of omega-3s to the rescue, like DHA? I think before we go down that street, it's important to understand that DHA has an ability, unlike any other long-chain fatty acid, to disrupt the lipid raft model, which really explains how the cell membrane allows particular molecules across in terms of transportation. And what happens is when you add a DHA-rich oil to this cellular lipid model, it starts to push the protein channels aside, and it starts to really displace the high levels of cholesterol and other types of lipids that are important for holding together that type of cell membrane integrity. So even the DHA-rich marine oil also has the potential, again, to cause higher levels of permeability, not only within the tight junctions, but within the cell membrane itself. So it's really important to question the addition of marine oils as much as it is the addition of omega-6 rich oils such as canola oil, corn oil, soy oil, most of those which, again, have been on our radar for some time. So now we've got another two pieces to this mosaic that I'm trying to create, and that's your polyunsaturated rich oils of both the omega-6 and the omega-3 variety, although I will note that flax oil, which is, again, an omega-3 rich oil, but it's not rich in the long-chain omega-3s, flax oil has not been shown to cause that type of disruption within the microbiome or that type of disruption within those tight junction and the level of permeability there. So we have omega-6 and omega-3 rich oils, especially the marine oils, and we have fructose contributing to both a breakdown in these tight junctions as well as some level of dysbiosis. Now, the next piece of this puzzle is one that I think most of us have heard something about along the way, but unfortunately, too many of us associate it only with genetically modified foods. And this is the herbicide glyphosate. Glyphosates are now, they've been shown in a variety of ways, whether we're looking at serum levels, we're looking at the amounts found in urine, we're looking at what's found in the average American, the average Western diet on the typical plate. It's been shown that we all have some level of exposure to glyphosates, even if we've chosen, by and large, a non-GMO and in some cases even an organic diet. And the reason being is that glyphosates, which again are typically used in higher concentrations on genetically modified plants because they will have a resistance to this herbicide, and that's what they were initially developed for. But glyphosates are now used in your non-GMO farming and in conventional grain and legume or pulse farming because they're used in what's called the browning process. And that process is used by farmers, and they're being taught this at your conventional ag schools around the world. This is common practice to make plants now dry in the field, to brown in the field. That's what the herbicide does. It will kill the plant because the plant is not resistant to this herbicide. And then the farmer can come through and harvest that material, which is already dried. It's lighter, so they have a reduction in fuel costs. And it doesn't have to be stored and dried in some type of indoor facility. So because of this more recent practice of using glyphosates on non-GMO crops, and in some cases on crops which have fallen under the label of being sustainably grown, which is very disconcerting. We all have some level of exposure. And the Moms Across America initiative has been really eye-opening for many people, looking at how much glyphosates are being found in public water supplies and in people's wells, especially if they're close to agricultural hubs. But what we're talking about here is, in terms of a glyphosate, we're talking about something that disrupts the shikimate pathway. And the shikimate pathway really, it's also called the shikimic pathway, that really allows a plant to produce the ringed amino acids, tryptophan, phenylalanine, and tyrosine. Now, those might not have, at first glance, those might not seem to be important to human physiology, but when you take a look at how the microbes within our GI are influenced because their dependence on the shikimate pathway is critical, you start to understand how glyphosates cause dysbiosis, a particular pattern of dysbiosis that I'm going to share with you in a few minutes, and how it also ends up causing problems within our mitochondria. So again, the shikimate pathway is critical for plants, and if you're a plant, let's say you are a particular herbaceous weed of some sort, and you lose the ability to produce phenylalanine, well, you lose the ability to produce things like anthocyanins or flavones or isoflavones. And, you know, I think when you look at this, you understand immediately, like, wow, those are antioxidants. I spent 4 years of my life researching anthocyanins in terms of what blueberries contribute to both mammalian and human health. When a plant loses the ability to produce these phytonutrients, then the plant loses the ability to defend itself against its environment. And that's how those plants, the weeds, which are exposed to glyphosates, that's how they're eliminated because they have lost the ability to adapt to their environment. Now, within the GI, because bacteria rely on the shikimate pathway just like plants, and this is really, I think, the gap between what we were initially told as to why glyphosates wouldn't have an impact on human health. It's because mammalian cells don't depend on the shikimate pathway. But at the time that the glyphosate was approved for widespread use in a variety of areas of agriculture, people didn't understand the damage that it would cause to the microbiome and to the important families of bacteria in particular that are very susceptible to it. So when a plant loses the ability to produce a particular phytonutrient, that plant dies. We don't get those phytonutrients from plants, of course, which are browned prematurely with glyphosates because that's going to interrupt this normal pathway. So our nutritional value of those plants will suffer as well. And again, glyphosates have been in very sharp increase in their use since the early 1990s. Initially, it was mostly corn and soybeans, but now you can see that there's a variety of foods. And the one on this that I feel is the most important is on pasture and hay, because when pasture and hay are browned in the field so that a farmer can go through and harvest them very quickly before the rainy season comes, and the grass-fed animals that hopefully you and I turn to, whether it's for our dairy product or, you know, for meat, that grass-fed animal product is now going to contain high levels of glyphosates because of the amount that were sprayed on the forage crop. So there's a lot of different levels that we can look at this, and in no way is it rosy at any level. I mean, if you start taking a look at a variety of different neurological conditions, and you look at the Pearson's correlation coefficient, and again, people will say, well, this isn't a clinical trial, this is cause and effect. Keep in mind that a Pearson correlation coefficient between lung cancer and smoking is 0.75. And we were told for years that, you know, we didn't have any clinical evidence that there was a connection there, right? Now we're looking at a Pearson's correlation coefficient of 0.985. When you get to 1.0, you pretty much have cause and effect. And we're at 0.985 with glyphosates and autism. And the mechanism, I think, will become more clear in a moment. So let's take a look at the glyphosate levels that are being found in some really common staples in the Western diet. You've got non-GMO grains, which are about 70 to 90 micrograms per kilogram, which means you're getting about, you know, anywhere from 30 to 45 micrograms in a pound of a non-GMO grain. Again, non-GMO. The GMO grains typically have much higher levels, but I'm not going to, for the sake of this evening's conversation, get into that. Organic grains, and I think this is a real eye-opener for people. In the company Tropical Traditions, they independently funded the research to test grains from all over the Northwest and in Canada for glyphosates, and they found that every batch they tested, oats, wheat, spelt, all contained 30 to 60 micrograms per kilogram of glyphosates. You take a look at organic lentils grown in Europe, 3.7 milligrams per kilogram. That's an awfully lot of glyphosate in a kilogram of lentils. Organic flax grown domestically here in the United States, 60 micrograms per kilogram. I'll show you what a 60 microgram, thanks to Brian, I'll show you what 60 micrograms looks like in a moment. Non-GMO soybeans, again, you're in the 3+ milligrams. Most people say, well, are there any conventional soybean products out? Absolutely. There are a lot of conventional, non-organic, but non-GMO varieties of tofu and other soybean products, edamame and things like that. So very high levels of glyphosates in those. Organic beer, what we can share with you is that while we don't have values, I know this would become really depressing, right, if I had a number up there tonight. And I'm not picking on you. I'm not. But the more things we learn about how rampant this is and how widespread it is, it's really sobering. There's no better word for it. But what we do know is that truckloads, whether you're talking to Don Huber at Purdue University or others who for years have been saying that glyphosates are causing problems with animal health in livestock studies, repeated batches of barley have been rejected, grown here in the United States as well as in Canada, by your big breweries because the glyphosates have stopped the fermentation process at the brewery. That's how high the glyphosate levels are in these conventional crops. This is what 60 micrograms of glyphosate looks like. It's visible. We're not talking parts per billion here. We're talking about a visible quantity. I give my 3 kids 60 micrograms of selenium every day. It's visible. It's an amount that their body recognizes and needs. So for people who say 60 micrograms of glyphosate is a negligible dose, when you really start to look at the research, and we're going to get into that now, on how high the levels are in urine samples, as well as what's been found in the blood of Germans, it's really clear. We have both acute and subacute exposure, chronic exposure at low dosages, which is very, very interesting because what that does, that type of exposure pattern with glyphosates, is it creates an environment where you're going to have much, much greater levels of propionic acid as opposed to butyric acid. And the two, even though they look really similar, are very different. This 3-carbon short-chain fatty acid, which does lower the pH of the intestinal environment, which is looked at overall as being very favorable, this is metabolized very differently by the human body. When you start to take a look at how that is, first of all, I've got to say that propionic acid is generated by Clostridia and the Clostridium family more than any other microbe. And you may be familiar between the relationship of Clostridia overgrowth and autism and a variety of other neurological conditions. But if you're not, McFabe is one of the leading authors on this area, in the area of autism research and dysbiosis. And time again, they find over and over, you find the exact metabolic biomarkers, whether you're looking at urine samples, you're looking at stool samples, whatever it is you're looking at, you find that children with autism typically have Clostridia overgrowth, and they typically have the absence of the conversion products that you need to spare the mitochondria some of the damaging effects of that propionic acid. So, and they typically have very high levels of microbial diversity, which also flies in the face of what, often we hear. The more diversity, the better. But again, the ratios, the presence of certain families may in fact be more important than the diversity absolute. So what happens is Clostridia, again, generating large quantities of propionic acid, especially when it's given a very carbohydrate-dense diet, which unfortunately, that is the Western norm, gives us these points of methylmalonic-CoA, which gets interjected as succinyl-CoA, which disrupts this entire Krebs cycle. And where that is most damaging is within the mitochondria of the central nervous system. When the propionic acid is at high levels because of Clostridia overgrowth, the mitochondria are exposed to very, very high levels of these interjectable metabolites that will really cut short the normal Krebs cycle, which is critical for allowing those nerve cells to generate the energy required for proper communication, nerve transmission. So this is one of the many mechanisms now that are starting to explain the relationship of glyphosate exposure to dysbiosis and the absence of particular bacterial families as well as overgrowth. Bifidobacter takes a hit. When animals are exposed to glyphosates, this has been shown in every animal study, whether you're looking at chickens or cows, when animals are exposed to glyphosates, the first population that suffers is Bifidobacter. And that, by the way, is one of the most difficult ones to get back. Once Bifidobacter disappears, now the body, unfortunately, loses the ability to detoxify your benzene-related substances. And we know that because hippurate, or hippuric acid, is what you look for in an individual who is detoxifying properly. When you start to see an absence of hippurate and hippuric acid, in the urine, then you know you have compromised benzene detoxification. This shows up time and time again with the absence of bifidobacter and with exposure to glyphosates. And again, I want to give great credit to Stephanie Seneff and Anthony Samsel, who for years now have been putting out papers on glyphosate exposure, dysbiosis. They've really been connecting the dots now for at least 5 years. And I've had a chance to correspond with Dr. Seneff on several occasions. And there are some papers that are coming out here in the next several months based on our correspondences that will fully illustrate and illuminate many of these connections that we're talking about. But there's a deeper layer to glyphosate exposure than simply causing the dysbiosis. And this, again, goes back to mitochondrial health. What happens is, if you look at the 1985 patent application by Monsanto for glyphosate use, what has been shown is that to make glyphosate, you're going to have high levels of glyoxyl and glyoxylate in the formula, which, by the way, you also find in soft drinks. If you look at the research, you find high levels of methylgalloxyl, glyoxyl, and glyoxylate in high fructose corn syrup sweetened beverages. The question is, do the high fructose corn syrup sweetened beverages have these fructose metabolites, or is it because the corn is typically GMO corn and has high concentrations of glyphosate in it as well, which are partially broken down into these metabolites? Either way, both of those glyphosate or fructose metabolites cause significant problems for human mitochondria. So, again, this is depressing at the end of the day. I don't know how much wine you've had, but I hope it's helped in some way. What are the solutions, really? Like, how is it now we can try to tighten up these gap junctions or tight junctions? How is it we can restore a healthy level of intestinal permeability? How is it we can try to foster, more diversity, but also having healthy families of bacteria, which we know have, very symbiotic relationships within our gene expression and things like that. I do want to emphasize the importance of accessible carbohydrates, microbially accessible carbohydrates. This is very different than the carbohydrates that are going to be found in particular types of fiber, and it's going to be very different than the types of carbohydrates which can be rapidly broken down in the more proximal small intestine and never survive to the point of where the microbes actually exist. So you need that happy medium. Fermentable fiber is a really important class of fiber. A lower carbohydrate density overall, which I'm going to show you a landmark paper published by Ian Spreadbury in 2009 in just a few moments. Having mostly glucose as the predominant monosaccharide that makes up your carbohydrates. Now, again, if you're not familiar with this, then you have glucose and fructose as typically the two most dominant monosaccharides or individual sugar units that make up the carbohydrate world. And if you're talking about something like high fructose corn syrup, it's about 60% fructose by weight. If you're talking about honey, and there's some good things we could say about a raw, unfiltered honey, but honey is still around 45 to 55% fructose, depending on, the variety of bee, the time of season, and things like that. When you get down to a sweet potato is only 4% fructose. That's a negligible amount. Rice and a white potato are 0 fructose and entirely glucose. These are really important details when you start to think about people who have compromised mitochondrial health, a high level of dysbiosis, and you're trying to really correct these imbalances on both levels. You can't continue to wash high levels of fructose, whether that's from the wrong fruits or dried fruits or fruit juices, because it's going to be very difficult for that individual on those two levels, at the gut level and the mitochondrial level, to get back to good health. And polyphenolic-rich foods, whether you're talking about berries or other substances that are rich in polyphenols, those have also been shown to foster the growth and development of very important bacterial families. So within the fiber world, the two that you want to understand, I think, the most closely are fermentable fibers, which tend to generate the greatest array of benefits, and the types of fibers you really don't want to count if you're trying to quantify the fiber intake of a patient or a population would be these two, the arabinoxylans and the brands. Some celluloses have beneficial properties, but by and large, bran is not the microbially accessible carbohydrate that something like a resistant starch is. And resistant starch means different things to different people. If you take white rice and you cook it thoroughly and you let it cool, even at room temperature, even if you don't refrigerate it, you have created a type of starch that will survive a significant percentage of the upper or proximal GI transit, and it will present the microbes within the distal small intestine, certainly in the colon, with a better food source than hot steaming rice, which, because it is still hot, has had a further, basically the starch hasn't been able to retrograde, and all your glycosidic bonds are very, very vulnerable to the salivary amylase, the pancreatic amylase, and that type of starch, white rice that's been thoroughly cooked and is still hot, will not survive to the colon with significant levels of microbially accessible carbohydrates. And the same can be said with a white potato. If you cook a white potato and it's hot and it's steaming, a very, very small percentage of that starch is going to feed the microbes in the distal GI. If you take that same potato, you boil it, you let it cool at room temperature till it becomes harder again, and then you cut that up and make a potato salad or something like that with it. Now you will present the GI with a very high percentage of microbially accessible carbohydrates. So the types of fiber we're talking about can be radically different if we go from bran to the fermentable fiber found in leafy vegetables, or if we go from the resistant starch that's found in a cooled, starchy food as opposed to one which is served hot. And Justin Sonnenberg and his wife Erica have done some amazing research on this. And it is important to have carbohydrates in the diet on a regular basis. The ketogenic diet, although I think it's very therapeutic and I recommend it for a lot of individuals who have particular patterns of health or disease, it's probably not the best overall for the microbiome that gives us the absolute best protection against inflammation and gives us overall the best tight junction. Now, a ketogenic diet can, of course, have a certain amount of resistant starch in it, but it won't be with a boiled potato or rice. It will probably be with adding potato starch or something like that that's much more elemental by nature. But it is important to have these microbially accessible carbohydrates on a very regular basis, whether that's 2 or 3 times a day is up for debate. But that should not be synonymous with a grain-based diet or a high carbohydrate-dense diet. And that's the real important difference that I want to explain. Again, this is the paper that I think is one of the best ever published on the role of a particular food group, or pattern of eating, and the microbiome and inflammation and overall insulin resistance. And again, this was published by Ian Spreadbury. He's had subsequent papers since. And it looks at what is it that happens when we present the microbiome with a food that's more than 23% carbohydrate by weight, which is in essence grains, flour products, anything that's heavily sweetened. And in fact, some lentils, some legumes are going to certainly fit that description as well. What you end up with is an overgrowth, typically in the small intestine and even in fact in the more proximal small intestine, of bacteria that produce lipopolysaccharides, which also open those doors or those tight junctions, really loosen those up. Generates a massive amount of inflammation. I'm sure that Dr. Perlmutter spent a considerable amount of time on this morning, so I won't belabor this any further. But it's been really established now over the last several years that carbohydrate density will trump glycemic index, glycemic load, grams of carbohydrate per day, because the carbohydrate density describes how the microbes are going to respond to that particular food. And that level of density, which, if it produces this overgrowth, the particular families of bacteria are going to generate the lipopolysaccharides and the inflammation that will travel downstream from that. And will also, of course, compromise intestinal permeability. If you take a look at all of these very traditional human foods, they all have very low carbohydrate densities, below 20%. It's only when you start to get into, again, grain-based and flour-based foods that you are presenting the microbiome with a food source that will allow their populations to reach unhealthy levels, especially those which have migrated further upstream within the intestinal tract. If we look at the trends going on globally, and more of our food is being sourced from outside the United States, it's really clear from agricultural research that antibiotics are being used in larger and larger quantities in both poultry as well as in other aspects of livestock. So antibiotic exposure is at an all-time high in terms of food residues. Despite the efforts put forth by the American government, there really hasn't been a strong effort by farmers to decrease their use of antibiotics as though we would expect. So this, of course, is another reason why you certainly want to choose, whether it's eggs or it's a dairy product or it's a meat, you want to make sure you choose an organic, non-antibiotic consuming animal. So in summary, what I look at as a blueprint for curbing inflammation, reducing inflammation by changing the microbiome. And again, it will take time, depending on the level of dysbiosis that's present, and in terms of improving the intestinal permeability to one which is healthy and it isn't too leaky, is try to keep the carbohydrate density of foods under 23%, try to keep polyunsaturated fats to less than 5% of total calories, and again, there's some evidence that 3% may be, in fact, even more optimal. Try to keep your fructose intake to less than 25 grams per day. Aim for more than 50 grams of fermentable fiber per day and sourcing that from non-GMOs. Avoid A1 beta-casein, so choose goat or sheep's milk cheeses. And if you're going to use yogurt or milk in your daily life, you really want to try to get that from either a Guernsey cow or a Jersey cow, which has been tested for its A1 content. And again, there's more and more farmers. I'm really thrilled. When I first talked about A1 and A2 casein 12 years ago, nobody had heard about it unless they were from New Zealand or Australia. And now I feel as many Americans have heard about this, many health professionals have heard about this, and a lot of small farms have taken it upon themselves to test their herd for their A1, A2 composition. I think if you enjoy dairy products, this is an absolute must to do. Avoid alcohol and polyunsaturated fats at the same meal. You're going to really get that, unfortunately, synergistic, perfect storm type of effect. And when it comes to glyphosate exposure, I think it's important to look at this on two levels. As a personal consumer level, I think you really want to make sure that you choose organic foods, you go beyond non-GMO, and you try to, whenever possible, at an activist level, do whatever you can to raise public awareness around how damaging glyphosates are to the human population around the world. Not just here, but if you look at the research in Colombia, you look at the research in Panama, to farm workers who are exposed to this and to populations who are eating much, much larger amounts of this, where there is no maximum residue level established, even though that one is very, very high for Americans. These populations are suffering in terms of reproductive health, neurological health. So we have an epidemic of conditions that are tied to glyphosates in one way or another. And I think it really is important for us as activists to speak out against this and to demand glyphosate-free food. Avoid antibiotics, residues in your food. And I think this is a really important one because, again, I think most of us have some level of exposure to something like glyphosate. We have had exposure to antibiotics in one way or another. Eat fermented foods, especially fermented vegetable foods like kimchi or sauerkraut. Eat those every day if you can. Taking a probiotic is good, but often the fermented vegetable food like kimchi or sauerkraut also provides the GI with a life raft with which those introduced microbes can survive on for a longer period of time, so they're not as transient. Taking a probiotic, I think, is an excellent thing in a lot of cases, but I think if you have the ability to eat a fermented vegetable dish, I think it's an even better choice. So I've also included in this talk some of the best papers that shed more light on these various aspects that we've covered tonight. And with that being said, I thank you for your attention. I'd love to answer any questions that I can. Thank you. This is for people in here who are RDs or maybe even MDs, it's a really touchy subject. I think raw milk has a lot going for it. And I think pasteurization destroys many of the beneficial attributes of milk. So I am a big fan of raw milk. If people are going to drink milk, I think that's the milk to drink. Also, of course, being a grass-fed animal from an A2 variety. I mean, it's only safe to drink if the farmer practices the proper hygiene practices. We can't expect, if you have 10,000 cows being milked automatically by a machine, and there's no visual inspection, and this really speaks volumes to our food supply, right? If you have 10,000 cows and they're in a feedlot type of system, which has a liquid-like manure. I'm not sure how much time you spend on a farm, but if you ever see the cow manure from an animal that's fed grain as opposed to an animal that's on grass, they're a night and day difference. I should have had a slide of this tonight, but I always say the proof's in the pudding. Animals that are on grain produce a very liquid-like manure. It's very messy, and when they eliminate, it splashes on the underside, very, very difficult for an animal to be grain-fed and for a farmer to produce a clean, hygienic, raw milk. The animals have to be on grass, that the milking has to have a certain level of visual inspection. It can't just be where you hook things up automatically and move to the next cow. So, these are a lot of problems with mainstream farming and agriculture. If you're dealing with a big farm factory, thousands of animals, a lot of automated processes, and it's grain-fed, I wouldn't drink that milk because I'm going to go out on a limb and say that a significant percentage of that milk is going to have a coliform that could present a challenge for people, especially people who may be immunocompromised. But if you're talking about a cow that is being milked by hand and it's on grass, that's the milk to drink. I hope that helps. You got to know your farmer. You really do. Yeah. It's a great question. It's $1 million question. I think more research needs to be devoted to that. We look at the immediate cause and effect, but no one looks downstream from that exposure. That's a great question. I'm sorry I don't have an answer for you. Yeah. And it may be how well it's absorbed before it reaches, right? Before it reaches the area where more of the microbiome lies. But I highly recommend one of several papers by Sanjay Ghosh, Ghosh. His work is impeccable, and he's had a really hard time getting his papers published in your larger, more mainstream medical journals, because what he has shown with the addition of marine oils to the microbiome and the inflammation is so contradictory to what a lot of us have been led to believe. It's really fascinating. And he's not alone. There are other researchers that have found similar results. Sure, Ghosh. And I'm not sure if you'll have, okay, but you can have, you guys can have this slide, so we can make this available somehow, right? We'll post this on our website. Yeah, so any of Sanjay Ghosh's work is, and this one did make a large, well-read journal in terms of the British Journal of Nutrition, but I consider him to be a real pioneer in showing that, marine oils are not going to correct necessarily everything that we've been led to believe. Again, there still may be a time and a place for them, but it might, we might have to consider more thought in terms of what's going on within the GI. Okay, well, thanks again, and have a wonderful evening. Thank you. Thanks a lot.